Hi everyone, so today's lesson is on recognizing linear functions from looking at or reading words, looking at tables, and looking at graphs. Okay, now before we go ahead and do anything, this is kind of like a review. We're gonna review rate of change, okay, which can also be called rise over run, which you guys are probably familiar with. So the first thing we are going to do is we are going to look at graphs and recognize whether something is linear or non-linear, okay? And I want you to take a second and think about what word is the base of linear, okay? So what word do you see inside linear? And what I want you to see is the word line, okay? That's going to be important. So what you're going to do is we're going to talk about if these four graphs, what is linear and what is not. So in order for something to be linear, we have to look for a straight line, okay? So in example 1, this would be linear because it's a straight line, right? And when I put SL, that just means straight line, okay? I just don't have enough room. Okay, so go ahead, go on and do the next. Now, this one, you have to be careful because it is a straight line. Even though it's diagonal, it doesn't change anything. This is still a perfectly straight line, okay? So this, once again, is linear because it's a straight line. Then we come to the third one, and you're going to ask yourself, is this a straight line? No, we see a little bit of a curve here. So this is something called a non-linear function, okay? Because it is not a straight line. And then the last one, once again, it is linear because a straight line. Okay? Now what I would like you to do is I would like you to use the vertical line test to determine whether 1, 2, 3, and 4 are functions. So remember, with the vertical line test, we're going to take a vertical line, we're going to just draw it down the graph and see how many times it touches. And all you're going to do is put function or not a function. So this one, it only crosses once. So this is called a function. Okay, and then we're going to do the same thing with the next one. Draw a couple lines. It only touches once. So this is a function. Okay, once again, drawing lines. It only touches once. So this is a function. With this one, be careful here. We talked about when we draw lines on top of a line. This is hitting at every single point on this line. So if I were to take like a green, it's hitting here and here and here and here and here and here. And it's very hard because it's showing you it's hitting at every single place. So it's hitting more than once. So this is not a function. Okay, so we need to be able to recognize what is linear and what is not by looking at graphs. And when we look at these graphs, you have to be able to tell me, 1, is it linear? And 2, is it a function or not a function? Okay, so that should be review and pretty simple for you. Now, these two definitions are the most important part of today's lesson, okay? We have to know these two parts of, we have to be able to remember these two things. So, a linear function is, it graphs to a straight line. So that's what we just talked about. Okay, so anytime you see a straight line, we know that it's a linear function. And also, it has, if a function is linear, it has a constant rate of change. Okay, and I will sometimes, or when I write this, I will call it the ROC, okay, rate of change, for time purposes and for space purposes. Now, rate of change, you guys have learned in 8th grade, so this is kind of just review. But what's going to happen is during this unit, we're going to go more into depth than you did in 8th grade, okay? So the rate of change is a formula that you are going to need to know. This is super, 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 super important. I'm going to star it, okay? And the rate of change is the change in y all over the change in x. That is our formula for rate of change, okay? And I'm going to show you exactly how to find the change in y and the change in x. But what's important about the rate of change is from the rate of change, we can tell if something's linear or not, okay? So if the rate of change is constant, okay, and another word for constant that is a little bit more familiar with us is the word same. So if the rate of change is the same, then it's a linear function. And I'm going to show you that in a few examples below. Okay, so these are the two important definitions that you need for today's lesson and that you're going to need for the following unit, okay? So if you need some more time to write that down, just pause it, but I'm going to go ahead and move on, okay? So now we are going to jump right into an example, and we are going to find the rate of change. We're going to find whether it's linear or not. But what we're going to do first, as I go through this, I'm going to write down the steps, okay? So our first step to finding the rate of change is find the change in x. So we're finding the change in our x values, okay? Now, you're going to watch as I do this. So you are going to ask yourself, what happened between 1 and 2? What occurred? You're always going to look for either adding or subtracting, okay? So what did you do to get from 1 to 2? And we know that's simple. We added 1, okay? Then, what did we do to get from 2 to, actually, on your paper, I'm sorry. Let me reiterate this, because on your paper, I think it's 0, 1, 2, 3, and 4. I don't know why my copied like this, but I think that's how your numbers are. But you're going to do the same exact thing. So you're looking for plus and minus, okay? And from 0 to 1, all we did was add 1. And 1 to 2, we added 1. And in order to get from 2 to 3, we added 1. In order to get from 3 to 4, we added 1. So that's how you find the change in an x. You look at your x values, and you see what happened for me to get from one number to the other number. And the only two operations you're ever going to use is plus and minus. Okay, you're not going to use multiplication, and you're not going to use division. You're only going to look, how many did I add, or how many did I subtract? Okay, now step 2 is to do the same thing, but just with your y values now. So now you're finding the change in y. Okay, so I'm going to do the same thing. How did I get from 7 to 11? My numbers went up, so I know I added something. And 7 plus what gives me 11? I added 4. I'm going to go to the next one. 11 to 15. Once again, I added 4. Then I went from 15 to 19. I added 4. And then I went from 19 to 23, and I added 4. Okay, so that's your step 1 and 2. You're just finding the rate, you're just finding the change. So what happened from one number to the next? Okay, now step 3 is to write each change as a ratio. Okay, and this ratio, all you need to know is the change in y all over the change in x, okay? And we're gonna look at ratios right now. So remember, it's your change of y all over change of x. That's how we're gonna write our ratios. And how we find our ratios is by looking at my changes in the same. So I have a change there. I went from 0 to 1 and 7 to 11. And you're putting your ratio as the change in y, which was 4, all over your change in x, which was 1. Okay? Then you're going to go to the next one and do the same thing. My change in y was 4. My change in x was 1. And then on again. My change in y was 4. My change in x was 1. Then again. My change in y was 4. My change in x was 1. Okay? So that's how you write a ratio. You're just looking at your changes and writing them as y over x. Your change in y over your change in x. Okay? Now, your last step is to ask yourself if it's linear or not. So, if the ratios are constant, okay, and we know the word constant just means same, then the function is linear. Okay? So, first thing you're going to ask yourself, we have the rate of change here, right? This is the rate of change, 4 over 1, 4 over 1, 4 over 1, 4 over 1. If those are all the same, then it is a linear function, okay? And why is because the rate of change is what? Constant. They're all the same. Okay? And then all that's saying is if it is linear, what is your rate of change? And whatever your ratios are, that is your rate of change. So in this case, your rate of change is 4 over 1. Okay? All right, we're going to move on, and we're going to do 3 more examples together, and you're going to be asked to do the rest on your own, okay? We're going to follow the same exact steps. So I'm flipping over. All right, we are going to look at 2a together. So the first direction of 2a is to plot the points from the given table, okay? So I'm going to make your ordered pairs. Remember, x comma y is an ordered pair, and you have all of them here. So your first ordered pair is 1 comma 0, check. 2 comma 2, check. 3 comma 4, 4 comma 6, and 5 comma 8. So I would like you to go ahead and plot those points. So you could pause and plot points while you do that, and then when you're ready, come back. Okay, I'm going to plot them as well. And then when you're done plotting, you're going to go ahead and draw a straight line in between your points. Okay? All right, I'm going to go on. So if you need to finish plotting, just pause and then come back so you don't miss anything. So my next step is to find the rate of, or to find the change in x. So I have to see what's happening here. So my first one went from 1 to 2. So there I noticed that I added 1. Then I went from 2 to 3. Once again, I added 1. Then 3 to 4. I added 1. Then 4 to 5. I added 1. So I did step 1, which is to find your change in x. Now we're going to find our change in y. So I went from 0 to 2. So I added 2. Then I went from 2 to 4. Once again, I added 2. Then 4 to 6. I added 2, and then 6 to 8, I added 2. Oops, I'm going to make those the right color. I'm sorry. I like to keep it color-coded. So plus 2, and plus 2. Okay? Now you need to go ahead and make your ratios. So you have a ratio here. Remember, change of y, all over change of x. So your y change goes first. So we had a 2 over 1. And then we go to our next ratio. Again, 2 over 1. Then the next, 2 over 1. And then the last one, 2 over 1. So what you notice is that they're all the same. So is this a linear function? Yes. Okay. Now, you're going to explain to me why. There's 2 reasons why here. Reason 1 is because the rate of change is constant. They're all the same, right? Or our ratios. Our ratios are all the same. And 2, you can tell from the graph because it is a straight line. Okay, so there's two reasons there. One, because you graphed it and it was a straight line. And two, because your ratios were all the same. And then that just means if it is linear, what was your rate of change? And that is what your ratios are. So your rate of change was 2/1. Okay? So that's how we're going to work with these. So if you need some more time, pause. If not, you can move on right with me. Okay, I don't want this video to be too long, so you're just going to have to pause as we go where you need more time. So with B, we're going to do the same type of idea first. You're going to go ahead and plot your points. So I'm setting up my graph, my table here, my graph here. Remember x comma y, and you have all of them here. So 1, 0, 2, 1, 3, 3, 4, 6, 5, 10. And go ahead and plot those points. I'm going to do it. You should do it while I do it as well. Okay? Okay, so I have plotted my points and drew my graph. Okay, so what we're going to do now is we are going to find the change in x. That's step 1. So I am looking at what occurred between 1 and 2. So what did I do? I added 1. And then 2 to 3, I added 1. Then 3 to 4, I added 1. Then 4 to 5, I added 1. Okay? So now we're going to do the same thing, but we're going to find the change in x. Change in y. So we just found the change in x. Now we're going to find the change in y. So once again, what happened from 0 to 1? I added 1. What happened from 1 to 3? How did I get from 1 to 3? I added 2. How did I get from 3 to 6? I added 3. And how do I get from 6 to 10? I added 4. Okay, so you've completed step 1 and step 2. You found the change in x and you found the changes in y. Now what you need to do is go ahead and make the ratios. Okay, so my first ratio is 1/1. Remember, change in y all over change in x. So all of your y's need to go on top. Then your next ratio was 2/1. Then your next ratio was 3/1. Then your last ratio was 4/1. Okay? And you're going to tell me, is this a linear function or not? You can tell me for two different reasons. So if it is a linear function, if all of your ratios are the same, you immediately can see that those are not the same. So this is not a linear function. So reason 1 is the rate of change / ratios are not constant or the same. Okay? And 2, you could tell in your graph. Your graph is not a straight line. Okay? And then this says, if it is linear, what is your change? You had told me it's not linear, so you can just put NA. There is no rate of change here. There's no constant rate of change. Okay? All right, and then we're going to do one more together, so pause if you need to copy this down. I'm going to do one more, and then you're going to try and do the rest on your own. Okay? All right. Let's look at, we're going to do 2C and then 3 together. Okay? So, same thing. Go ahead and graph. My graph looks a little bit different than yours, like my actual graph right here. So just try your best to do it on your own. Okay, I'm going to also do it on my own, but ours may look a little bit different, okay? So 0, 9, 1, 1, 6, 3, 0, 4, -3, and 5. You may have to go past your chart a little bit when you make this graph, okay? So if you didn't know how I got those points, x comma y is 1 here, then another, then another, then another, then another. Okay? I will write them down over here just in case you need them. So at this point, you should have your points plotted. If not, pause so you can get that done before we move on to the actual finding our ratios. Okay, so same thing. We're always doing the same exact thing, but this one's a little bit different now. So I do not want you to just try and do it on your own. I need you to pay attention, okay? So same thing. First step is to find my change in x. From 0 to 1, what did I do? I added 1. From 1 to 3, what did I do? Sorry, I'm going to just change colors. I added 2. From 3 to 4, I added 1. And from 4 to 5, I added 1. So what you notice different here is they're not all the same, right? You have 1, 2, 1, 1. All right? Now, we are going to move. Now we're going to do your change in y. So we're looking here. From 9 to 6. Now, I did not add here. Remember, you can either add or you could subtract. So how did I get from 9 to 6? I subtracted 3. Okay? Then, how did I get from 6 to 0? I subtracted 6. Then, how did I get from 0 to -3? I subtracted 3. And then, how did I get from -3 to -6? I subtracted 3. Okay, and now you're going to go ahead and make your ratios. So, remember, change in y all over change in x. Okay, now it's important to keep your signs here. So I had, remember, your change in y, your bottom's coming first. So I had -3 over 1, -6 over 2, -3 over 1, and -3 over 1. Okay? Now, I want you to ask yourself, do not write anything down right now. I want you to ask yourself, do you think this is linear or non-linear? By just looking at your rates here, by just looking at your ratios, does that look linear? You're probably going to answer no, because they're not all the same. But this is super important, because when we complete these ratios, you can always reduce if you need to, okay? If I look at -6 over 2, this can be reduced. If I divide both of these by 2, I will get a -3 over 1. So what would happen is this would no longer be 6 over 2, but it would be -3 over 1. And now, I'm going to circle these. All of these are the same. So what's important is you have to remember to reduce. If something can be reduced, you need to reduce it. Okay? So now what you're going to do is answer that, yes, this is linear. Okay? And 1, it's linear 1 because your rate of change is constant. Okay? And 2, your graph is a straight line. Okay? And then lastly, if it is linear, what was our rate of change? And we know that our rate of change here was -3 all over 1. Okay, that's your rate of change. So if you need time to look that over, go ahead and do. I'm just going to answer number 3. So now that we've seen graphs of several functions, explain how you can determine if a function is linear by just looking at the table. And what we were just doing there by doing our +1, -1, whatever it was we are just looking for patterns in the change of x, in the changes of x and y. Okay? So what you are going to do now is go ahead and try numbers 4A and 4B on your own. Okay, so keep this on for like the next 30 seconds. I'm going to just explain everything. We are doing the same thing we were just doing here. Okay, find your changes. So do your little bubbles. Then write your ratios on the side. Okay, and so on. Then C and D are the same thing. Now, 5 is where it gets a little bit different. So now you don't have your x values. So you have to find, you don't have your y values. So you need to find them. And how you do that is you take your x values and you plug them in for x. So now you have y equals, or for the first one, you're going to do 3 times -4 minus 8. And this will get you -12 minus 8, which is a -20. So this will go here. And then you do the same thing again. 3 times -3 minus 8, and then 3 times -1 minus 8, 3 times 0 minus 8, and 3 times 5 minus 8. Okay, fill that out, and then follow your steps. Same thing with B and C. You're filling them out. Use your calculator. Don't try and just do this all in your head, okay? So same thing with B and C. And then 6 is just a little bit of a word problem, but you should be fine. Really, nothing is changing. You're still doing the same thing, okay? If you have any questions, let me know.